What is projectile motion? Projectile motion involves any object propelled at any angle falling under the influence of gravity. Projectile motion differs from linear motion as it includes horizontal and vertical components. Projectile motion can also be seen in many sports and also in things like cannons. With the spread of cannon fire in the 1500s, projectile motion started to become studied more. Galileo rejected Aristotle's theory and formed the first theories about projectile motion and how it worked.
When dealing with projectile motion, we assume air resistance is non-existent in the horizontal direction, and that there is constant gravity in the vertical, which is negative 9.8 meters per second squared.
Since projectile motion deals with the x and y axis, we use trigonometry functions to determine each individually. Sine is used to determine y direction values, and cosine is used to determine x direction values. To solve the variables, we use the kinematic equations. Delta y, initial and final y velocity, and gravity are all used for the vertical direction. Delta x, initial and final x velocity, and acceleration, which we'll just assume doesn't exist, are all used for the horizontal direction.
There are two main scenarios for projectile motion. In these examples, the focus object begins on the ground.
For this example, we can use the protractor in the video and the yard lines on the field to get some rough measurements. By using the protractor, I determined that Michael kicked the ball at 30 degrees, or pi over 6, and that he kicked it with a velocity of 23.7 meters per second. Using cosine, I found that the initial x velocity was 20.5 meters per second, and using sine, I found that the initial y velocity was 11.8 meters per second. Using the kinematic equations, I was able to find the height it would have risen to had Matt not stopped it, the total distance it would have gone, and the total hang time it would have had. When comparing these to the video, they seem mostly accurate. I used three different kinematic equations for this one. First, I solved for delta y, which was 7.1 meters. Second, I solved for time, which was 2.4 seconds. And third, I solved for delta x, which was 50 meters.
Another example would be when a golf ball is hit.
Again, we can use rough measurements to find our variables. Again, using the protractor, I determined that Anthony hit the ball at about 43 degrees and that the initial velocity was about 30.4 meters per second. I found that the x velocity was 22.2 and that the y velocity was 20.7 meters per second. Using the same equations, I found that the ball reached a peak of about 21.8 meters and went a distance of about 88.8 meters. I also found that it had about a 4-second hang time. For this one, I used the same three kinematic equations. First, I solved for delta y, which was 21.8 meters. Second, I solved for time, which was 4 seconds. And third, I solved for delta x, which was 88.8 meters. All of these measurements were pretty close to what the video showed.
The other scenario of projectile motion is when the focus object starts above the ground and falls, like serving a tennis ball, or more severely, falling off of a cliff.
Using the same strategies, we can figure out the same variables of an object that starts in the air instead of on the ground. Since we couldn't use a protractor on this one, I found that the initial x velocity was about 27 meters per second, and that the ball reached a peak of 2.5 meters before I hit it. Using this, I found that the ball was in the air for about 0.7 seconds and traveled about 18.9 meters before hitting the ground. For this one, I only used two of the kinematic equations. First, I solved for time, which was 0.7 seconds, and second, I solved for delta x, which was 18.9 meters. And when compared to the video, both of these were accurate.
To recap, projectile motion deals with an object being propelled at any angle under the influence of gravity. Gravity has the constants of negative 9.8 meters per second squared.
Using the kinematic equations, we can find velocities and distances of objects in motion like we showed in our examples.
So what did I say?
Hardcore parkour.
If Bridget takes us... Yo,
Are you coming?
I left my house. Hurry it up!
Anthony!
You came!
Hang over there.
Like Happy Gilmore.